Hi everybody. So today we're going to learn how to do some very simple basic conversions within the metric system itself. And one of the reasons we need to do this is because the way we measure things and the way we calculate things are often very different. Now what I mean is this. Whenever you do a physics equation, when you do calculations in physics, you must be in standard units. You must be in kilograms, meters, and seconds to properly calculate things. But that is not the most convenient way to measure things. For example, if I wanted to know what the diameter of this little ball was, I wouldn't want to measure it in meters. I mean, there it is next to a meter stick. Can you tell me how many meters the diameter of that is? No, that would be ridiculous. What we're more likely to do, of course, is to measure it in another unit like centimeters or millimeters. That would make more sense. Equally, here's the same ball next to a kilogram. Now, could you tell me, looking at it, how many kilograms that little ball is? No, again, that wouldn't make sense to measure it that way. What I would more likely do is put on a balance and I would measure it in grams. But again, I can't use the gram in a physics calculation. It must be a kilogram. Could you tell me how many seconds it took me to drop that ball? No, again, the second wouldn't make sense. You would have to do it in a shorter unit, like milliseconds. But the second is the standard unit for calculation. Now, I could technically drop the ball here in slow motion, but that doesn't give me an accurate time. So that doesn't do me any good. Here I have a map of the Grand Canyon. Now, would you want to tell me how many meters long the Grand Canyon is? No, that wouldn't make any sense. In fact, even in the scale on the map, they ramp it up to even a 10-kilometer length of measuring things. So the kilometer is a better idea on measuring something of vast distance. Equally, would you want to say how many seconds it would take to sail down the Colorado River from one end to the other? No, you would more likely do that in hours or even days. But again, those units make sense in terms of measurement, but you can't use them in a calculation. You must be in kilograms, meters, and seconds. So how do we go about doing these simple conversions? Many teachers deal with this different ways. First of all, you have to understand something called metric prefixes. And those are those things like milli and centi and kilo and things like that I've talked about. Those of you who've had some familiarity with the metric system, you may have also learned some other prefixes like hecto, deca, and deci. You probably want to unlearn those three, simply because we don't use them in science. They are not typically used as scientific measuring prefixes. But prefixes we do tend to use. Well, I put them together here on what I call a little staircase. Now again, teachers do this different way. Each one of these prefixes has a certain name. The capital G stands for giga, capital M, mega, which you may know those terms from like gigabytes and megabytes of data. The K represents kilo, one you're probably familiar with. I'm going to skip that little C in there. It's something a little bit different. The little M stands for milli. Now this other letter right here is the Greek letter mu, but in metric it means the prefix micro. Micro meaning very small. And the N stands for nano, as in nanotechnology, something you may have heard about. The base is an important location on here because that's where we always want to be. That's where our standard units tend to be in physics, is a base unit. So for example, here I have 30 millimeters. Now, I want it to be a standard unit. Now, if you generally want to know what the base unit is, it's always the second letter. Okay? So if you cover up the first letter, the second one is always your base unit. So in this case, that would be meters, which means your first letter represents one of the prefixes, in this case, milli. So my goal is to convert 30 millimeters into the base unit meters. Now, how do I do that? Well, one of the important things is to recognize what each step on this staircase really represents. The idea is that each step will represent a factor of 1,000 or 3 decimal places. And again, in science, that's typically how measurements are done, by every factor of 1,000, okay, not necessarily 10 or 100 or something like that. So what that means is, if I start off with 30 millimeters, that means I'm starting down here at milli. And I'm going to go one step up to the base. So that is a factor of 1,000. The other aspect of this staircase is, if I'm going this way on the staircase, it's kind of like I'm going to the left, which means I will move my decimal left. If I'm going this way on the staircase, looks like I'm going to the right, which means I'll move my decimal point to the right. So what does this all mean? Okay, so I want to convert 30 millimeters into meters. Well, I start off with 30. Again, I am at milli. I'm going to go to the base, which is 1 step, or 3 decimal places. It's also heading left. So what that means is I need to move my decimal 3 places to the left. So 30, well, my decimal is hiding out here at the end by the 0. So that means I need to move it 1, 2, 3 to the left. Now, whenever there's an empty space, I just put in a 0. So that means that 30 millimeters is 0.03 meters. And that's as simple as it is. I need to know how many steps did I take, and every step is 3 decimal places. So let's look at another one. Here I have 25 kilometers. K, the first thing, is the prefix. M, the second one, is the base unit. So that M is what I want, meters. Kilo is right here. The base is 1 step down, or towards the right. So that means I'm going to move 3 decimals to the right, because it was 1 step on the staircase. So I start off with my 25, my decimals at the end, and I want to go 1, 2, 3 to the right. So 25 kilometers is 25,000 meters. Again, all there is to it. All right, then let's look at a little trickier one. Now, this says 2,000. The prefix, the first letter, is that Greek letter that means micro. The base unit, the second one, is an S for seconds. So obviously I want to convert 2,000 microseconds into seconds. Micro is down here. Well, that's 1 step, 2 steps to get to the base. So that's a factor of 1,000 twice, or 6 decimal movements. 3 decimals for every step. And again, it's headed to the left. So I start off with 2,000 with my decimal point, and I go 1, 2, 3, 4, 5, 6, putting in 2 zeros. So 2,000 microseconds is 0.002 seconds. Again, that's all there really is to it. However many steps you are, you keep moving those decimals 3 at a time. All right, 400 grams. Now wait a minute, there's no prefix. That means we're at the base. Hey, great. Unfortunately not great. So this is sort of our one time in physics we don't go to the base. And that is because the base unit for mass is actually the kilogram. It's the only physics unit we use all year that is not on the base. Okay? So whenever you have mass, you actually want to be getting to the kilo part. So in this case, I'm starting on the base and I'm going 1 step up or to the left to kilo. I start off with my 400 and my decimal. 1 step is 3 decimals going left. 1, 2, 3. So 400 grams is 0.4 kilograms. Again, mass is the only standard unit that is not on the base. All right, one last example is something that a lot of scientists don't use, but we find very convenient to use every day. And that is this other prefix, C, which is kind of hanging off the edge here, which stands for centi. Now, again, it is not a typically scientifically used measurement. They usually use milli if they're going to do something smaller than the base. But measuring things in centimeters is really convenient for a lot of what we do in physics. So we want to kind of talk about it because it's a very convenient unit, much more often than millimeters. Centi means 100, which means instead of 3 decimal places, we move 2 decimal places in order to get to the base. Now, we typically only see this with length. You don't measure things in centiseconds. You don't measure things in centigrams. It is predominantly associated with just length. So here I'm going to convert 30 centimeters into meters. Now, as you can see, it goes left to get to the base, but instead of 3 decimals, centi is going to be 2. So 30 centimeters is 0.3 meters. So basically, when we're looking at this, We always want to go to the base, except for mass, which is going to go to the kilograms, to K. Each time we're moving 3 decimals for every step, except for centi, which will only be 2. So those are kind of our exceptions. Now, of course, what happens when you get a situation where there is more than one unit, or you have things like area and volume? Well, we're going to look at that in a different way next time. See you next time.